Greetings, peoples, and welcome to my first ever sponsored product review. A company approached me wanting me to test one of their products and do a video review on it, and they gave it to me for free, but that does not mean for a moment that I'm going to just say it's wonderful and there's nothing wrong with it. There are pros and cons. We're going to go over it. It's a very, very popular product, and if you stay tuned, you're going to get a coupon code that's going to give you a heck of a lot off on Amazon. What product is it? It's the Jackery Explorer 240. Let's go check it out. HOBOTECH. Oh boy, have things come a long way since then. That review was before the professor was even born, and guess what? I still have that very first Jackery, and it works perfectly. Fast forward nearly 6 years, and we go from Jackery selling tiny 500 cycle, 240 watt-hour camping generators to massive 5,000 watt-hour whole home backup systems rocking 4,000 cycles. But the big question on everyone's mind is it any good? Let's find out. HOBOTECH. The Explorer 5000 packs a 5,040 watt-hour lithium iron phosphate battery rated at 4,000 cycles to 70%. This is by far the biggest and baddest Jackery ever made, and it certainly feels like it, weighing it at 135 pounds, measuring 25 inches tall by 15.5 inches wide and 16.5 inches deep. Now I think that extra inch is for the wheels, which stick out in the back. As for the display, it has the typical modern Jackery display that offers input and output watts, time to charge discharge, battery percent with spinny little icon, and more than a dozen other indicator icons. This product does have both high and low temperature protection, so you won't be able to damage the battery in extreme conditions. This jacked Jackery has a massive 7,200 watt pure sine inverter with a big trick up its sleeve. It has both 240 volt split phase and standard 120 volt outlets that work simultaneously, which is unlike much of the competition. On the front, you get 4 20 amp standard outlets split into 2 pairs, and each pair supports up to 3,600 watts per pair with a maximum of 2,400 watts per outlet. On the side, you get a 240 watt NEMA 1430R 4-prong twist lock receptacle and a 240 volt NEMA 1450 that doubles as both a 50 amp RV hookup and 50 amp appliance hookup. So yes, you can plug in your electric oven, electric dryer, or 240 volt well pump and power them easily. You can also charge your EV with a level 2 charger for those inclined to do so. As for ways to charge, the 5000 can charge from standard 120 volt grid power at 1800 watts for charging the built-in battery in about 3.5 hours. Now if you opt for Jackery's smart transfer switch, you can charge with 240 volt split at 4000 watts for topping up in only 1.7 hours. Note, getting their transfer switch is the only way to charge with 240 volts. There is no special adapter cable. In fact, it's written right on the side, 120 volts only. As for solar, the 5000 has 2 MPPT solar controllers with 3 inputs. The low voltage solar inputs are a pair of standard Jackery proprietary 8020 or 8mm barrel plugs wired in parallel that supports 16 to 60 volts at 10.5 amps each, or combined at 21 amps, for a maximum of 1,200 watts of solar. Now, if you plan to use Jackery's new 500 watt portable panel, 2 of those plugged into the low PV port will charge the unit in about 6.5 hours under ideal conditions. You can use your own solar panels on the 8mm inputs if you buy both an 8mm to MC4 adapter and a 7909 to 8020 adapter. Both of those I do have available on my website at gohobo.io/adapters. However, for the first time in history, they're offering standard built-in MC4 connectors for their high voltage solar input, which supports from 135 volts all the way up to 400 volts of solar. So you can plug in any basic solar panels that you like without any muss or fuss, with one big caveat. And that is, you need to have enough solar panels in series to reach that minimum of 135 volts in order to just start charging. Now at 135 volts, the minimum voltage for that, you'll see this in the upcoming test, that you can only send in 2000 watts at 15 amps. So That's at that voltage. What you're essentially going to want to do is stack your panels up high enough to try to get around 200 volts, and that's where the Jackery's MPPT really kicks in and will let you charge at the 4,000 watt maximum. And at that rate, it's going to charge from solar in just under 2 hours. Giggity, giggity, giggity. Note that the 5000 doesn't officially support 12 volt charging from a vehicle, but in my testing, I found that it actually does at 100 watts through the low voltage PV input, which yes, is ridiculously slow and would take more than 2 days to charge, but hey, it's possible. And by the way, if all this volts, amps, and watts is like another language to you, check out my Hobo University playlist where I teach you what all this techno jargon mumbo jumbo means. Now, as for 12 volt outputs, this Jackery offers a single 12 volt cigarette lighter style socket, good for running something like a 12 volt fridge. It supports up to 10 amps and is regulated at 13.2 volts. As for USB outputs, the 5000 at least offers a well-rounded set of USB ports, starting with a pair of 100 watt USB-C power delivery outputs and a pair of 18 watt quick charge USB-A ports. Finally, somebody in 2024 ditched those basic dinosaur ports. Now, for other features, this Jackery wouldn't be a home backup system if you couldn't add more batteries to it. It does offer battery expansion through a port on the side that allows you to add up to 60 kilowatt hours of batteries, or 3 days powering all loads in the average American home without even recharging, using these 5 kilowatt hour expansion batteries I'll put up here on the screen. Up to 5 can be chained up to one Jackery 5000, and if you opt for that smart transfer switch, you can hook up a second Jackery 5000 with another 5 batteries to reach that 60 kilowatt hour maximum. Note that Jackery does offer a free service that will help you in finding a local installer if you do opt into that transfer switch purchase. As for warranty, Jackery offers a standard 5-year warranty on this product. And of course, we took the Jackery Explorer 5000 into my secret laboratory where I performed all kinds of crazy experiments, including, yes, of course, a double-fisted bang, bang battery capacity test. As for the results of the test, there was no DC battery capacity test since it would take over 50 hours to discharge this battery through this cigarette port, and no one's going to buy this for its basic 12 volt capability. Instead, I did a separate 120 and 240 volt AC test to see if there was any difference in efficiency between the two. Now, as for the 120 volt test, it scored 4,450 watt hours for a solid 88%, while the 240 volt test scored a virtually identical 4,440 watt hours. Now, this result was not a surprise to me, as this unit does not run 2 separate inverter circuits like others do. This inverter only does 240 volt split phase, and that's 120 volts on one side, 120 volts on the other, and then they match those together for 240 volts. They simply run the split legs all the time. So it works exactly like the circuit breaker box in your home, which is why this is designed to be paired with their 240 volt transfer switch. Now, a note for our foreign friends, our 240 volt grid service is split into 2 120 volt alternating phase circuits running at 60 hertz, where yours is single phase 240 volts running at 50 hertz. So I'm going to assume Jackery is going to have a completely different inverter for the EU and Australian market. Now, of course, we did the phantom load or parasitic drain test. On the AC output, the Jackery used 515 watt hours over 6 hours, or a whopping 2,060 watt hours over a 24-hour period. So if you left the inverter on with nothing plugged in, it would totally kill this battery in under 2.5 days. And if you want to know what that works out to, it's 85 watts. Yeah, 85 watts just to have the inverter turned on. Now, granted, this is a big power-hungry 7200 watt, 240 volt inverter, but EcoFlow's Delta Pro Ultra also has a 7200 watt honkin' 240 volt inverter, and it uses only 52 watts at idle. Now, this is Jackery's first all-in-one 240 volt home backup solution, but they really need to work on that idle consumption. Now, as for DC consumption, fortunately, the DC side fared a lot better. I ran both the 12 volt and the USB at the same time at idle with nothing plugged in for 12 hours, and it used zilch 0. That's right. Jackery always had some of the best DC circuitry, and if I recall, they were the first to put 12-volt regulation circuitry all the way back in 2018, or maybe it was even earlier than that. So they've obviously mastered DC aisle consumption with regulated circuitry. Now I'm always asked how long stuff's going to run on these products, so compensating for usable capacity, which we just figured out, you can pause this chart I'm going to put on screen and you'll see approximately how long combo appliances will run on this unit. Pure sine wave check under load. From the outlets up front, we have a perfect 120 volts, 60 hertz. And for 240 volts, we have 238 volts, 60 hertz. Before we start the inverter capacity test, where we determine how much power you can pull out of the inverter, I need to explain something special about this Jackery, and that is the fact that it is a split phase 240 volt inverter only. Unlike a lot of the other power stations which have a separate 120 and a separate 240, this only has a 240 volt, but that is split into two 120 volt circuits. So how Jackery set this up is that these two outlets are on one of these circuits, and these two outlets are on the other circuit. So these two outlets combined can do 3600 watts, and these two combined can do 3600 watts. And when they're combined together over here on the side, that's 240 volts. The best way to describe this is by looking at this color-coded adapter. This adapter takes 240 volts through a 4-prong twist lock and splits it up into two 120 volt circuits. So you have two outlets each, and you can actually see there they're color coded. So you have 120 on these two and then a separate 120 on these two. And if you were to attach these two together, you get 240 volts. So that's how this Jackery works. This is really only a 240 volt inverter that's split into two 120 volt circuits, just to put it in layman's terms. So it's a split phase 240 inverter. There is no separate single 120 volt inverter on this. So when you turn on the AC power, it's 240 volts and 120 volts at the same time. So the 120 comes out the front, the 240 comes out the side. Keep this in mind when we're testing. So what I'm going to do first is I'm going to do an inverter capacity test on one outlet, which is going to be a 3600 watt maximum. Then I'm going to have to plug this into something that can draw 7 kilowatts, which I really only have one thing, and that's my main home system. So let's start with the 120 volt circuit, 3600 watt. And in order to do that, I have this heavy duty cable. All right, we're at 37, 38, 39, 4000, 4100, 4200, 4300, 43, 44, 45, 46, 47, 48. At 4800, it goes out, and that is right where it should be. This next test is going to be a Jim doozy, because I have 3 heaters on the floor and 2 big power stations. It's still not enough to push this to 7200 watts, so I am dusting off a good old friend of ours, the solar degenerator. Dun, dun, dun! So with this, I have each one of these circuits pretty much balanced the best I can at 3600 watts. That's where we're going to start. Should start around 7200. Then I'm going to increase it with the solar degenerator until this thing shuts off or I run out of power. I have nothing else I can plug in. This is about 8,000 or 9,000 watts worth of stuff. Okay, we're at 64, 68, 7,000. Kick in the solar degenerator. We're at 8,000, 8,200, 8,500, 8,800, 8,900, 9,200 watts, 9,300 watts. That's everything I got. Everything is on high. 9,300 watts, and it finally trips after about 10 seconds. Now that was pretty incredible. 9,300 watts, it ran close to 10 seconds. That is impressive. Good job, Jackery. Okay, I have the Jackery hooked into my home system with a 240 volt cable going across the room into my transfer switch, and I am currently running almost 7,200 watts. So we're at 71, 7,000. My second or third time trying this. If I push it more than that, it will trip. But let's just do it for the camera. I'm changing my generator setting here. I'm changing my gen rated power there from 7.2 to 7.3. And of course, as soon as the camera refocused, it shut down. So I can't really push it any harder than that, but that I consider a pass. Now, as silly as it is to do this test, I'm going to do it anyway because I know someone's going to complain if I don't do it. So here we go. And this is a 15 amp saw. Of course, it's going to run at no problem because it has 3,600 watts on each circuit. So child's play. Okay, the 5-minute sustained cooling or heat soak test. That's where we push the inverter to its limit for at least 5 minutes to make sure it doesn't do anything crazy like start smoking or drinking or partying or pooping in the neighbor's yard without picking it up. You know, you can't be pooping in your neighbor's yard. So what I'm going to do to make this test fair, since this is two 120 volt circuits of 3600 watts each, I'm going to put 3600 on one side, 3600 on the other side to get 7200 total. Just to prove to you that I'm keeping the load balanced, I do have it right now running at 3600 watts on the first circuit. See right there, we're pretty close to 3600 watts. Okay, there we go. There's the second circuit doing 3600. Let's go ahead and plug all this in. We should get 7200 watts combined. There we have 7200 watts. There's the clock. Let's come back in 5 minutes and make sure everything's okay. All right, we're coming up here on 5 minutes, and this room is getting quite hot. I've been running all these heaters at 7,200 watts. So yeah, it's getting quite hot in here. I'm gonna go ahead and turn all this off after I measure the decibels. I'm gonna have to turn some of this equipment down so it doesn't interfere with the test. Now, of course, as soon as I turn the loads down, the fan spun down, so it's not as loud. It's gonna be really difficult to do this test because I don't have enough silent loads. So from a meter away, the fans are about 43, 44 decibels. They are very quiet for the amount of load that we're pulling on it. Another difference between the Delta Pro Ultra and this Jackery 5000 is that below 2000 watts on the Delta Pro Ultra, it's completely silent, where we do actually have at 1500 watts some fan noise. Max charge rate test is where we use this variable voltage charger to do simulated solar into the solar inputs on the Jackery 5000. Now it says here in the manual, this thing has 3 MPPT ports on it. So 3 solar ports, but it only has 2 solar controllers. So the first solar controller is for low voltage from 16 to 60 volts, 10.5 amps per barrel plug. Because Jackery is still, for some reason, using the 8mm barrel plugs, they're amp limited, so you can only push 10 amps through it before they start to melt. So they provide 2 of those in parallel. That means you have to put the same amount of solar panels on each side. So if you put 400 watts on one, you got to put 400 watts on the other. You got to be the same voltage, the same amps. You can't mix and match anything with those 2 MPPTs for the low voltage range. That's the 8mm, the 80/20 ports. 16 to 60 volts, 10.5 amps each for combined 21 amps. Now it also, for the first time in the history of Jackery, offers MC4 inputs. Yay! They finally, only took them since 2018 to finally offer a product with MC4 on it. So the MC4, however, is a high voltage MPPT controller. That's a separate controller. It supports from 135 to 400 volts. Now, I don't have any way to test 400 volts. My charger here goes up to 200, so that's what we're going to do. So the port can take 15 amps, which is typical, 4 kilowatts. So 4,000 watts from the high voltage side, 1,200 watts from the low voltage side. So combined, that would obviously be 5,200 watts. I only got this one heavy duty charger. This thing is quite expensive, so I only have one of them. But let's start with the low voltage range. I don't have 2 of these cables, so we're going to have to see if we can push 20 amps through one for a short period of time to see if we can get that 1,200 watts of charging. All right, at 13 volts, it's pulling just under 8 amps and allowing you to charge at 98 or we'll just say 100 watts. This is for charging from a car, cigarette lighter socket, or from a 12-volt battery. So let's take it up to the next level, 24 volts. So you have a 24-volt battery or a 24-volt vehicle that you'd like to charge with. Now at 24 volts, it's actually going to pull 20 amps and allow you to charge at around 450, 500 watts. It's fluctuating quite a bit because it doesn't know what to do, but it looks like it's going to go ahead and pull 500 watts at some point here. So it does actually tag 500 watts if you wait long enough. I don't understand why it's being so fluctuating. Yeah, it's touching up here on 500 watts. I think what might be happening is that the port is trying to limit itself on the amps, since it can only support 10 amps for each input. 48 volts is going to be 2 smaller solar panels in series or 1 large solar panel. Okay, a 48 volt battery or a large solar panel runs at 50 volts nominal at 20 amps. 900 watts is what I'm hitting here. So let's take her on up to 60 volts, which is the maximum for this port. At 60 volts, we're doing 1157. I saw there for a second. Yeah, this thing's all wonky because it doesn't seem to like the way I'm doing this through one port. But I did see 1157 a couple times, so we're going to go ahead and call that 1150. which is close enough to 1200. So yeah, that test is a little bit wonky. I think it's because I'm trying to push too many amps through one of those barrel plugs. It's kind of freaking out. So the inputs that the Jackery uses on this are proprietary 8020 barrel plugs. So what I call them thick pins because the inner pin is very thick. It's not like a standard 7909 barrel plug that you find on other power stations. So let's scratch the 8mm and move on to the good MC4 connectors and see what we can push through those. Okay, I'm now plugged in with the same charger through the MC4. I have to say, Jackery, this lid is a very bad idea. EcoFlow, they have it so it's either removable or it slides in. So this doesn't seem like it's removable without breaking it. I couldn't figure out any way to easily take it off, but it's really seriously in the way when you're trying to plug things in and pull things out of there. And then they do give you a special MC4 disconnector tool to remove these. I simply didn't push them all the way until they clicked because it'll take me forever to get them unhooked, and I don't have that kind of time today. I want to get this done. High PV minimum voltage is 135, so let's just start there at 135 volts. Okay, as soon as I approached 135, I heard it clicking. Let's see what it's doing. Okay, 135 volts. It's pulling its maximum of 15 amps. We're getting 2,000 watts. That's a lot better, and it's noticeably a lot more solid now. So it has nothing to do with my charger or the way it's working. It has to do with Jackery not liking that I was pushing all that power through the low PV last time. All right, well, this is a 4,000 watt charger and the power station I have on the floor is 3,600 watts. So I'm gonna have to plug this thing into something that can handle 4,000 watts. I'll be back. Got a 4,000 watt inverter power station in the other room. I'm gonna go ahead and use this super heavy duty 20 amp cable and hopefully this will do it. Okay, we're gonna just max this thing out 220 volts. It might peg 15 amps, let's see. 15 amps, it's trying. No, it is not liking that at all. 25, 28, 2800 seems to be, oh, 3,500 I saw for a split second. 3,000, yeah. Unfortunately, my charger is only 120 volts. Oh well, so this is the first time on HOBOTECH that a power station has beat this. This is 4,000 watts, but the problem is it's 120 volts. So even though I have a 4,000 watt inverter over in the next room, it's on a 20 amp outlet. So it's just not able to push the 4,000 watts into this thing. Quick update, I'm able to get a solid 3,000 watts at 206 volts. If I go 1 volt higher, it's too much power for my charger. So 3,000 watts, we were at least able to nail that constantly. Next is AC charging or charging from a grid or a generator. Now, by default, it is set up to maximum charge rate. I believe it's supposed to be 1,800 watts. It's currently charging at 1,670. And the battery is discharged to 57%. I have run a bunch of tests on this, so it's a little warm. It's probably not going to give me the maximum rate from AC power. But inside the app, you can change it. So I had no problem getting the app to work. There's not a lot of options in it. You have 2 choices for charging from AC. You got fast charging mode or quiet charging mode. So let's switch it to quiet. Now it says there it will reduce the noise to 30 decibels. You can see there the charge rate has dropped to 1,400 watts, so I wouldn't really consider that much of a loss. Now it is pretty quiet. The fans are running. It's not silent, so let's see how quiet it is. Okay, around 42, 43 decibels. Let's put it back on regular charging mode and see the difference. That's a little strange. It still says 42, 43 decibels, but the fans are definitely louder in maximum charging rate. Now, I'm not saying that the fans are loud. I'm just saying that they're louder than they were on silent mode, and that's strange from a meter away. I can't tell a difference. Now, I bet you if I put this up against where the fans are, we'd notice a difference. But since I measure all my tests from 1 meter away, which is a standard decibel reading for one of these products, we're going to stick with 43 decibels. Now, what about simultaneous charging? Can you charge it from both AC and DC at the same time? Say you have a gas generator, a propane generator, and you have solar, but you don't have enough solar. So you want to be able to supplement charging, try to get this thing charged as fast as you can. Say there's a big storm coming, power went out, you got your propane generator cranked, and you got a couple thousand watts of solar on an array. Right now I'm charging from the wall, AC power. It's supposed to be 1,800, it says 1,680. We'll call that close enough. Let's put on solar. Now remember, I can only do 3,000 watts with this, but let's see what the combined total is gonna be. So everything shuts down and a bunch of clicking happens. There we have the 3,000 watts of solar. And here comes in the AC wall power. It's kicking in slowly. 38, 39, 4,000. I think that's the upper limit of charging for this. It does say we're getting 4,100, but I remember here in the user manual it said 4,000 watts was the max charge rate. So we're able to push it around 4,100, and of course my fake solar just shut down from an overload. But there you have it. You can actually do 4,000 watts of combined solar and AC charging. And that's 120 volts AC. What if you want to charge this with 240 volts? Well, guess what? Your SOL, unless you buy their Smart Hub, because the Smart Hub is the only way to charge this with 240 volts. It says right on the side where you plug it in, 120 volt only. You have to buy their smart transfer switch in order to charge this directly with 240 volts. Now they sent me one. That's beyond the scope of this video. I'm not going to bother with that this time. Really, this video is going to be plenty long enough. The Jackery 5000 offers a single 12 volt output. No barrel plugs, no high amp output. So 13.07, round that out to 13.1. That's a little on the low side. Let's actually test the output. So it can handle 10 amps at 12.5 volts. So it does pass the test. Jackery 5000 offers a pair of USB 100 watt power delivery outputs. So I have them plugged into my fancy little 140 watt power banks. These can actually input or output 140 watts of USB each. Every video people ask me about these, how do you get them, where I get them. I'll go ahead and put the link here on the screen and also in the description of this video if you're interested. You can see here they are charging at 96 watts apiece. So if you can see that, they're both doing 96 watts. And on the Jackery, we're getting 200 output from the pair of USB. Note the USB is on its own switch compared to the 12 volt cigarette lighter socket. Jackery offers two different flavors of UPS or uninterruptible power supply features. One is backup mode. That's the standard mode that you get in most power stations. That mode has a relay inside the power station that will switch from wall power to battery power. When you're plugged into the wall and you're using your appliances through the outlets here, the power goes out, that relay switches, takes the battery power, sends it through the inverter. Now this also has what's called online UPS mode, which you can actually set through the app, and that is 0 milliseconds. It doesn't actually switch at all. It just runs off the battery all the time. Now there's a benefit to each one of these modes. The backup UPS doesn't use the battery at all, so it doesn't hurt the battery over a long term. Online UPS, however, is something that is using the battery all the time, and over time that's going to wear down the battery. So it's one of those features you don't want to use for a long term, meaning like months on end. Now, if you're dealing with a severe storm, lots of power kicking on and off, and you're going to have sensitive equipment hooked to this, you could simply put it in online mode and run it that way for a couple of weeks. It's not going to hurt the battery. It's really only going to mess things up if you're doing it for months and months or years and years, which a lot of people do. They plug these things and they forget, and they leave them on. If you're in online mode, it's going to hurt the battery over the long term. So backup UPS mode is the default, and that's the same kind of UPS mode you get on most other power stations. It actually switches using a relay from the grid to the battery. So what we do to test this, to make sure that it's 20 milliseconds or faster, because that's what Jackery says in the manual, 20 milliseconds or better, we have a full desktop PC here running a music video in HD, and that's running out of the outlet here. I do have the battery charging from the grid. You can see 1400 watts there. I'm going to go ahead and play the music video, and then we're going to count down, hit the switch. That's going to cut off the grid, and we're going to see if the laptop continues to run, if it freezes up or acts weird. Then we'll switch to online UPS and I'll show you the difference. Let's go ahead and switch off the grid power. Thunderstorm, lightning, here it comes. 3, 2, 1. All right, no problem. PC is still running the video just fine. This is a full Intel i5 processor, not some weak sauce. Let's go ahead and turn on the power again for the charging. Oh, and we actually did lose the desktop that time. That's interesting. What's really strange is that it actually just shut off the AC inverter when I kicked the power back on. Now, it shouldn't have done that. We're going to have to test this again. Okay, let's do this again. I'm not going to bother getting online to play the music video. I just want to see if the PC shuts off or not. So here we go again. 3, 2, 1. All right. No problem. The PC does stay on. Now let's turn the power back on again. That time it's fine. So now let's go ahead and run the music video. Okay, let's try this again. Third time's a charm. So the music video is playing. Let's go ahead and turn off the grid. 3, 2, 1, lightning storm. PC is fine. Let's go ahead and turn the grid back on. 3, 2, 1. Okay, that must have been some kind of fluke, because the first time it tripped the inverter and shut that off. Let's do it again real quick. Okay, multiple power outages and power coming back on simultaneously didn't affect it at all. All right, so I'm just going to consider that first fail a fluke. So now we're in the app, we're going to switch it from backup UPS to online UPS. Okay, there's a clickety click of the relay. Now let's try it again. Now here's something I noticed, very interesting. When I switched it over to online UPS, the fans all of a sudden kicked on and got a lot louder. It was pretty much silent. Now it's running off the battery and inverter all the time, even while it's plugged into the grid. So when we switch, it's 0 milliseconds. There is no actual switch. So I can go all day long, switch this off and on. It does nothing, because all it does is stop charging the battery because that PC is now running fully off the batteries. That's the difference between online and backup mode. Another thing you have to realize is that when you're in this online mode, there is no 240 volt outlets. So the 240 volt outlets on the side are completely disabled. These 4 outlets still work, but you're limited to 3,600 watts total. So this is no longer a 7,200 watt inverter, it's a 3,600 watt inverter because it's only using one side of it to supply 120 volts. There's a couple of severe limitations putting this in online mode, but it is the best mode if you have a lot of lightning strikes and power clicking on and off a whole bunch of times and you're concerned that whatever equipment you have plugged in isn't going to survive all that switching back and forth. Remember, these products with UPS modes do not have surge protection built in. It's just passing grid power straight through. So if 1,000,000 volts comes in from a lightning strike, it's going to pass 1,000,000 volts through the outlets into your products. So I always recommend everybody, if you're going to run sensitive computers during a bad storm or any time where the electricity may not be stable, you want to put a strong UPS on the incoming lead, not on the outside, but on the incoming, and that will protect the power station and everything plugged into it. So let's quickly check out the app. There's not a lot to it. So you have this main screen, which gives you the very basic information, input, output. And down at the bottom, you can choose between off, 2 minutes, or 2 hours for the screen. Now, if you're one of those people that don't read the paper user manual, you'll never know that you can actually just double tap this power button to keep the screen on indefinitely. I like to keep the screen on all the time while I'm using the product. So that way I don't forget that I left it on, right? Double tap, bang, bang, and that screen will stay on until the battery's dead. So I always use that option. Now here's the thing to remember. When you power off and power back on the Jackery, it wipes that setting. It actually sets it back to 2 minutes by default. So no matter what you have set in the app, you turn the power station off and back on, it resets it to 2 minutes. I'm hoping a firmware update fixes that. It should remember your last setting in the app. Speaking of settings, it's very basic. There's one other screen with some settings on it. So you can share the device, you can change your charging settings, we already went over that. Battery settings will allow you to switch it between fully using the battery and 80%. UPS, we went over that. Energy saving mode will turn the thing off after a certain period of time. Charging plan lets you set up certain times a day you want to charge and discharge, and there's the auto off time for hibernation. And below that you have firmware upgrade, and very simple, very basic app. It does work on both Bluetooth and Wi-Fi. The only problem I've had is once I put the Wi-Fi in, it doesn't want to reconnect again. It only wants to go back to Bluetooth. But it seems like now it's working on Wi-Fi. I can see the Wi-Fi signals lit up, so now I've decided to use Wi-Fi instead of Bluetooth, even though I'm sitting right next to it. But it works. It's not great, but it does work. Musician's favorite amp interference test. This is where we determine, is the inverter clean or dirty? Is it suitable for use with amplifiers and PA systems and ham radios and stuff? Now, being this is the flagship product, the most expensive thing that Jackery sells, if it doesn't pass this test, I would throw it in the dumpster. So let's hope I don't have to throw it in the dumpster. So place your bets. Is it clean or dirty? Okay, it's exactly what I would expect. It is absolutely crystal clean. AM radio interference test. This is just for your own information, so let's go ahead and turn on the power. That was interesting. It sounded like R2-D2. All right, USB, DC, AC inverter. Wait for it to click. That's actually not bad at all. That's very clean. So very little, if any, AM radio interference. So this is a pretty clean inverter. I'm surprised because almost all inverters at this distance from their AC outlets is going to give some kind of AM interference. Nope, not this one. Next is the EMF, or electromagnetic interference test. This is what you know, does it give off EM radiation, which is a concern if you run ham radio equipment or anything sensitive and you don't want this equipment to disturb things in your environment. So Let's test it. Okay, so base reading around 1 to 2. That's about normal for this room. I do have my cell phone and everything turned off and away from my person. Turning it on doesn't seem to really do much. A couple of relay clicks, not really. It does go up a little bit. Turn on DC. That's normal. Let's go ahead and turn on the inverter. Seriously, that's it? This might be the lowest I've ever seen. It's barely reading anything at all. I get it really close to the outlets, but I always kind of measure it from a little bit away. So yeah, wow, very low EM readings. It's very low. So I'm a little bit closer to the 240 volt. You can see it is registering a little bit higher, but it's still very clean. Thumbs up Jackery on doing very good shielding for this product. It's shielded from EM and AM radio interference. Now to tackle the literal elephant in the room that you guys have been waiting for this whole video. Testing the extra battery. Now this is an additional 5 kilowatt hours on top of the 5 kilowatt hours that this comes with. So it's actually a very compact 10 kilowatt hour system. I would say it's probably one of the smallest I've seen, and it's still lithium iron phosphate. So it's not like Jackery cheated by using cheaper batteries or something, or NMCs. Nope, they're actually using lithium iron phosphate, which is safe, not going to explode. The downside is this is the cable they give you. It's literally like a foot long. They do include 90-degree angles, so they got the memo. They got the 90-degree angle memo. I don't think you can really put these on top of this, because if you do, the cable's never going to reach that port. So I'm guessing you're supposed to put the batteries next to the unit. And then if you have 90-degree angles, I guess you gotta do that. So I guess, I don't know, let's find out. So I've never hooked this up before. This is the first time doing it. So you might be able to barely see that, 30%. I didn't charge it at all. I purposely didn't charge it because I want to have a low battery with a high battery and see, does it recalibrate or not? Because the last couple Jackeries with battery extensions did not. Okay, well, I guess that worked. Guess I can't really turn it much without doing some kind of damage. 63%, that's what I was charged at before. This is coming on. Let's give it a minute to recalibrate. It does say there's one battery there, but it is not recalibrating. Let me go ahead and turn the whole system off. I'm going to unplug the battery. I just want to double check because this is a pretty serious issue for a whole home backup system. This meter should calibrate to how many batteries you have set up, because otherwise, how do you know how much power do you have? I'm going to give it one more chance, and I'm going to check the app and make sure there's nothing in the app that I'm missing. All right, I'm not smoking crack today. It is detecting the battery just fine. There you have it. It says the current power level of the battery is 30%, so it is detecting it and calibrating it to the system. And check this out. Even the app doesn't calculate the extra battery in its calculations. It still says 63%. All right, that's some pretty major weak sauce coming from a flagship product from a major name brand. They're not recalculating. I don't think a single Jackery does this, and it's something that I think is vital, especially in a home backup system. You want to have a bunch of batteries stacked up. Say you have 6 batteries connected to this thing. They're all going to be different charge levels. You're going to look at this and say, okay, I'm at 63% on my whole system. No, just this battery is 63%. All the other ones could be random percentages. They could have different charge rates and stuff going on. So the fact Jackery doesn't calibrate on the main screen, or at least on the app, at least do it on the app, to me, that's just extra weak sauce. So what do I think about the Explorer 5000? If I'm being honest here, I do have mixed feelings about it. Let me explain. On one hand, it's nice to finally see Jackery release a whole home backup system. On the other hand, they're about 2 years too late. On one hand, they built a fantastic product with a very quiet inverter, one of the quietest on the market that has some of the best RF shielding I've ever seen. And on the other hand, that inverter consumes an insane 85 watts at idle. On one hand, you get Jackery's fantastically efficient regulated DC circuitry. On the other hand, you get a measly single 12-volt socket that doesn't even have a rubber insert. On one hand, you get both Bluetooth and Wi-Fi remote access. On the other hand, the app is janky and the Wi-Fi disconnects itself a lot. I was trying to remotely monitor this thing while I was doing the time lapses from another building, and I ended up half the time coming in to check on it in person because the Wi-Fi would just disconnect. Jackery, you really need to work on that app. Now, on one hand, the extra batteries you can get with the unit are very compact, simple, and very easy to hook up. On the other hand, they don't stack with the main unit and they can't be rolled around if they're connected. You literally have to disconnect all the batteries and carry them around separately to move to another location. I'm not really sure what the engineers were thinking there. Now, there's some things I applaud that Jackery did with this design. First, this super compact form factor is a huge win. None of the competition has something this small and portable and powerful with a chunky 5 kilowatt hour battery built in that could be easily wheeled around on its own. Others have to use dollies or carts or snap-on wheels, and some just offer nothing at all for mobility. I also give Jackery a huge kudos on keeping this thing whisper quiet even under high loads. Now, it's not the quietest power station I've ever tested of this size, but it's definitely in the top 3. Last but not least, thank you, Jackery, for finally using standard MC4 connectors on one of your products. This is going to make so many folks happy, and I bet twice as many of these are going to be sold simply for this one feature alone, because I know so many people out there will not buy a Jackery because all they use are those darn 8mm barrel plugs. Now, viewers, if you agree with my opinion about those 8mm ports, leave a comment in the description for Jackery below because they are going to be reading them. Now, what about product price? It's actually not as bad as you think. The 7200 watt Jackery Explorer 5000 is currently on sale for only $34.99. That's their flagship 5 kilowatt hour Jackery at 69 cents per watt hour or 49 cents per watt, depending on how you want to look at it. In the past, Jackeries typically launch at 80 cents to $1 per watt hour, making this a pretty solid deal. But wait, there's more. Jackery is giving viewers of HOBOTECH, that's you, an exclusive discount code that knocks an additional 3% off that price. That's going to save you $100 just for watching this review. Now, what about competition? This thing is going up against EcoFlow's Delta Pro Ultra and Bluetti's AC500. Now, the EcoFlow is $1,150 more even if you factor in all the discounts. And the Bluetti with 5,500 watt hours of batteries and 2 inverters, if you want to count 240 volt split phase service, is $500 more. But those pair of AC500 inverters combined do offer a little bit more power at 10 kilowatts. Now, they all offer similar 5-year warranties, so it really comes down to the features and form factor that's most important to you. Now, the Jackery by far has the smallest footprint in pretty much every dimension you can think of, and it's probably the lightest if you factor in the built-in battery. So if you need your power to still be really mobile, the Jackery is the easy winner. However, when you add in a bunch of extra batteries, you lose that mobility because there's no way to reel them all around together, and they don't stack on top of the main unit. They only fit next to it, which I found odd. They should have at least put wheels or provided a trolley or some kind to put the batteries on so you could wheel them all together across the smooth surface. I do feel the Jackery is the best option if you need something really compact that can run all the major loads in your home or power your remote cabin, boat, RV, or something at a campsite. Just don't get it wet. It has no waterproofing ability whatsoever, and you can tell because they didn't bother to even cover any of the outlets on the side. So if you're interested in this product, the link and discount code is going to be in the description of this video below. I'm also going to put a link here at the bottom of the screen, along with a QR code that you can scan if you're watching me on TV. They'll take you on over to the Jackery store page, where you can check out this pretty fantastic, awesome new flagship, the Jackery Explorer 5000.
Odin commands you to like and subscribe, and clean my litter box.
If your search for something is a pain in the neck, go to YouTube and watch HOBOTECH, cause he's a testing this and he's a probing that. He's even been probing Odin's cat. If you wanna get all the Odin back, go to HOBOTECH. Yeah!